All right, guys, welcome to another episode of Cuda Education. Today, I wanted to talk about um, just expand a little bit more on this idea of tracerayEXT. Now, first of all, tracerayEXT is not a it's not a built-in Vulkan function. It's actually a function from GLSL, which is the shader language. So if you notice that both in the hit shader when we're launching the shadow test ray or the shadow ray, and also in the raygen shader when we're actually launching the rays, we use this tracerayEXT. But these are only exclusive to these are only exclusive to the shader portion of the code, right? So this is sort of after the fact or ancillary, if you will. Um, we launch rays here and we launch rays here, right, for the shadow test, and this is for the general rays from the camera, okay? But yeah, tracerayEXT is a it's a it's a shader language function, a GLSL function. It is not necessarily part of Vulkan itself. I mean, obviously Vulkan has something to do with it. And if you notice that in order for these functions to be available in your shader language, you need to make sure you have the ray tracing extension on your system. This is why I always say, if you want to run the ray tracing algorithms, you need to make sure, if you want to run the ray tracing algorithms, you need to make sure that you have a ray tracing capable GPU. And this is the reason why. You need to have these extensions. So we require the extension in the raygen shader, and we require the extension in the hit shader. All right, so we both call the tracerayEXT, and as a result, we need those extensions. If you remove these extensions and you try and compile the shader into SPARE-V format, you're going to get a compilation error. It's not going to allow you to do it because you're calling a function that requires ray tracing capabilities, right? So that's the first thing. The second thing that I wanted to discuss is that really and truly, all of this stuff, all of this stuff in terms of the ray tracing shadows application, it's initially being launched by vkCmdTraceRaysKHR. So this is like the Vulkan function that initiates everything. So, obviously we run our application and we get our we get our we get our we get our shadows, right? And we get our application, okay? Fair enough. But this is the initial firing of everything that happens after it. So of course we have our shader binding tables, the raygen, the miss, the hit. That's sort of the parameters. We have our command buffer draw call, width, height, etc., etc. Okay, but this is the guy that sort of initiates dispatch the ray tracing commands, right? And this is all within the command buffer generation. So we're now in the command buffer region, and we are now we're basically doing a for loop for all of the frames and everything for for all of the command buffers and all that we're doing. You notice that we're looping over I, all that stuff. And we launch with this thing. Now, the funny thing is that if I remove this call, I leave everything as is, but I just remove this call. Okay? I remove this ray tracing call from Vulkan, right? If I do that, here is what happens. I get a blank screen. And notice how the frames per second is through the roof. The application is running more efficiently. The application actually runs. There are no crashes. There are no compile time errors. There's nothing. And the reason for that, and notice that the frame rate is through the roof. The reason for that is that we simply removed the ray tracing call, right? And that's a telling sign. We could simply remove the ray tracing call and everything else still runs fine. Okay? So this call is what really pushes and starts everything going forward. This call in particular is what this VK, and as I've always said, anything with lowercase VK, you generally know that you're talking about Vulkan, an important Vulkan function. Lowercase VK function, you know you're talking about an important thing. Now, I put back in my command, you know, I build and run the application, and we get back our rays, right? And notice that the frames per second falls a bit, right? So again, we take it out and we get a blank screen, but the application still runs, right? And we get way more frames per second and stuff, right? All right. So that's pretty much all I wanted to cover. In order, you know, this tracerayEXT, we spent a lot of time in the previous video talking about it. And I just wanted to give you some more details on tracerayEXT, right? Everything is initiated from this vkCmdTraceRaysKHR. That's what Vulkan ignites everything else that happens in the chain of command. Okay, and in the next video, I'll do a whiteboard on sort of fleshing out all of this stuff right here. But that's the key to getting everything to run and getting everything started. But you know, we have to go through some more details to sort of get a better understanding of the bigger picture. But I just wanted to add this video because you know, I didn't fully address the tracerayEXT function in its entirety. And of course, we have our flags and all that stuff. I hope you guys did your homework. You're supposed to know what these flags are, the call mask, all that stuff. And then, of course, remember that you need that extension required in the shaders in order to run the tracerayEXT function. All right. All right, guys. Remember, if you want to be able to run these examples and get involved, get your hands dirty into Vulkan, not just hypothetical, not just sort of in theory, you got to get tutorial number 1 that installs the Vulkan API on a Windows-based machine with a Vulkan-capable GPU. If you want to get these examples, you need tutorial number 13. It installs all of these examples. However, if you want to run the ray tracing examples, you will need to make sure that your GPU is ray tracing capable. For NVIDIA, it is RTX series and greater or later, right? For the other vendors, I don't know, Intel and AMD, right? But for NVIDIA, we're talking RTX cards, okay? And that's pretty much it, guys. Thanks for watching. Have a great day.